where everything originated from. Although the most widely accepted theory is the Big Bang, scientists still can't prove every little detail. The theory was discovering cosmic microwave background radiation, also known as CMB. CMB is a huge cloud of radiation that is left over from the Big Bang. When the Big Bang occurred, everything created became a hot soup, and after 380,000 years of expansion, it began to cool. In space, we are able to see the bright things, such as stars and planets. However, we cannot see the things that are cold or that have less energy. This is why we cannot see the CMB, because over time it has gotten very cold. CMB is negative 270 degrees Celsius, and that is nearly 3 degrees more than absolute zero, the coldest temperature.
For a long time, humans didn't know that CMB existed. In the 1960s, scientists were looking for something similar to it so that they could prove the Big Bang Theory. Actually found by accident in 1963 by the scientists Arno Penzias and Robert Wilson. They created a radio receiver and began to hear unknown signals. They thought the sounds were interference from pigeon droppings on the antenna equipment, so they cleaned and protected it from the pigeons and realized that the droppings had no effect on the sounds that they heard. As funny as that sounds, pigeons helped in the discovery of CMB.
Now, microwave background radiation is not visible to the human eye. If you recall the EM spectrum, only a tiny portion in the middle is visible to us. Everything else we can't see. The CMB is on the far end of the spectrum, right here. You might be wondering, how does this prove anything about our universe if we can't see it? With the creation of the Wilkinson Microwave Anisotropy Probe, this type of radiation has become visible to scientists and allowed them to get a detailed look at the CMB. NASA launched the WMAP in 2001, and it was sent to orbit 1.5 million kilometers from the Earth.
It was positioned to make use of the Earth-Sun Lagrange point L2 to use minimal fuel and keep the WMAP sensors pointed in the correct direction, away from the Earth and Sun. It's a location where two gravitational forces combine and create a point of equilibrium. The WMAP had improved resolution and accuracy when compared to the COBE.
By using different radiometers between 2 points in space. It created the first full map in detail that shows the differentiation of temperatures of the CMB. It mapped temperature fluctuations in the CMB and found that certain parts of space were colder than others. Scientists found this related to density of matter during the early stages of the universe. This means that it carries information about formations of cosmic structures like galaxies, clusters, and voids. That led to the confirmation that our universe is expanding, the expansion rate and contents of the universe, when the first stars ignited, and the age of light in space.
This could come to the conclusion that the universe is expanding, because as it does, the CMB photons are redshifted, which simply means that the wavelength of light is stretched. This shows that the radiation is moving away, but we can tell it was once close. Think of how you can see a car's taillights move away from you, but you know that it was once next to you.